In this video, we'll discuss how to name and write formulas for ionic compounds that have polyatomic ions. So polyatomic ions, they're molecular compounds with a charge. Polyatomic, multiple atoms, nitrogen and oxygen, that's multiple atoms, with a charge, ion. So ions have charges, so it's multiple atoms with a charge. There's a type of polyatomic ion called an oxyanion, and that's a polyatomic ion that has oxygen in it. And the name is based off the number of oxygens in the formula unit. Now remember that polyatomic ions are molecular compounds. See these examples? You have covalent bonds, but you have either extra electrons or you have too few electrons, which gives it a charge. So these will act as a unit. You can't break these apart in the formula. So the oxyanions, the most common form is the version that ends with 8. Chlorate, for example. So there are other polyatomic ions that have chlorine and oxygen and a charge, but chlorate is the most common. Another example would be phosphate. There are other polyatomic ions that have phosphorus, oxygen with a charge. Now, if you have another form of chlorate, but it has one less oxygen than chlorate, we would change the ending to "ite." So chlorite, instead of ClO3, it's ClO2. Notice how the charge is the same. The charge will not be different. Phosphate, instead of PO4, 3 negative, we have PO3, 3 negative. Now, if your polyatomic ion has 2 less oxygens than the most common form, we have to give it a prefix. It would be hypoite. So chlorate has 3 oxygens, but hypochlorite only has 1. It has 2 less oxygens. Phosphate has 4 oxygens, but hypophosphite has 2 oxygens. Now if it has 1 extra oxygen, we give it a different prefix and we keep the 8 ending. So per8. Chlorate with 4 oxygens instead of 3 is perchlorate. Phosphate with 5 oxygens instead of 4 is called perphosphate. Notice in all of these, the charges are the same, right? All of these phosphates are, they all have a 3 negative, and then the chlorate family, they all have a 1 negative. So the charge will not change, it's only the number of oxygens. When you're naming ionic compounds, you name the cation and then the anion. And then don't forget about the naming system for oxyanions if you have those. Writing formulas, you'll just do swap and drop, and you do not break up the formula for the polyatomic ion. It has to be the same number of each type of element. And then sometimes you need parentheses if there's more than one polyatomic ion in the formula. So example, calcium and nitrate. Calcium ions and nitrate ions form calcium nitrate. We use swap and drop to write the formula. So swap the 2, swap the 1, and then that gives you CaNO3, 2. There are 2 nitrates, so we need parentheses. If you only had 1 nitrate, you would have no need for the parentheses.